I have some really bad news. Your data probably aren't interval. I have an experiment I want you to run. Take a look online and see if you can find an example of interval data that doesn't use temperature. I looked at all of these sites and found that each of them uses temperature in Fahrenheit or Celsius scales as their prime example of interval data. I'll put the links in the description. I also pulled these off my shelf and they use the exact same example. Fahrenheit and Celsius are good examples of interval data, but they might be the only widely known and technically accurate examples of interval data. In order to figure out what else might constitute interval data, we have to define our term. Both interval and ratio data assume even intervals between points on a measurement scale. Imagine an ant walks in a straight line along a ruler from the 2-foot mark to the 5-foot mark. That ant has traveled 3 feet. If another ant does the same thing from the 6-foot mark to the 9-foot mark, it too has traveled exactly 3 feet. We can say that both ants traveled the same distance because, on our measurement scale, the gaps between the points of measurement are equal. The gap between 2 and 3 on a ruler is the same as the gap between 3 and 4, and so on and so forth. Even intervals distinguish interval from ordinal data. I'll talk about how to distinguish between interval and ratio data in the next video. For now, let's really focus on why this point is so sticky. In social research, Likert scales are commonly used. They are also often used as if they are interval data. Here's an example of how it might be employed. What is your opinion on the color orange, with the options strongly dislike it, neutral like it, or strongly like it? If we want to meet the assumptions for interval data, the gap between each of these options has to be equal. In order to figure this out, we need to figure out what our unit of measurement is. In our ants example, the unit of measurement was feet on our ruler. But what is the fundamental unit by which we can increment on this scale? Is it, like it? 1 like it? If one person answers 1 and the other answers 4, is that a difference of 3 like-its? Like-its don't make any deep conceptual sense. Certainly not in the way that a degree on a Celsius scale or a foot on a ruler do. If the argument about the lack of a fundamental unit of measurement doesn't convince you, let's consider instead that it doesn't even make conceptual sense that these gaps should be even. Do me a favor. What's your favorite food? Maybe even write it down if you have a pen nearby. Now, think of another food that you eat fairly often, but you wouldn't mind giving up forever. You like it, but you could give it up. I'm going to argue that your favorite food would probably be scored a 5 on this scale. You would list it as strongly like it. I would also argue that the second food you picked would probably go in the like it category, at least if you played along honestly. Last premise. I would argue that most people would reasonably answer a 3 to this item. How much do you like the taste of water? Since I can't hear your answers, I'll give you mine. I like squash, but I could give it up. My all-time favorite food is chicken Alfredo with pasta and marinara sauce added. The sauces combine so nicely. Oh, it's so good. The gap between the taste of water and squash is noteworthy. I do like squash. There is a gap in how much I do like those two things. The gap between squash and chicken Alfredo is massive. I like one of these so incredibly much more. It's not even close. This stupid scale makes me treat those differences as if they are the same, and they're not. They're not. It makes way more sense to rank these and to recognize that the gap between 1 and 2 is massive, while the gap between 2 and 3 is just noteworthy. The uncomfortable truth is that Likert scales and agreement scales are probably just rank data that we've been erroneously using as if it is interval. This distinction is important because if Likert scales are rank data, we shouldn't be doing parametric statistics on them. If you want to read more about this argument, check out Susan Jamison's article. It is a wonderfully concise and well-sourced primer on this issue. Next up, ratio data. Thanks for watching.